Hey everyone, Joe here. In this video, you're going to learn what a fuse is, how a fuse works, and how to fix a blown fuse in a car. If you want to just jump ahead to the actual car application where we're going to be digging around, pulling fuses out and testing them, I'm going to put a timestamp at the bottom of the video description, and you can skip ahead, or else you can just wait around and learn the theory part about it. So this is how a typical automotive fuse looks. They come in a bunch of different sizes and they look very similar. You'll notice here we have a number, 10. We'll know what that means in a second. So a fuse is basically just a safety device that prevents electrical fires. What I'm going to do is I'm going to draw a circuit that does not have a fuse in it and illustrate how an electrical fire can happen. So to start, I'm going to draw a battery. And a battery has a positive and negative terminal. This battery is going to be the source of all the electrical energy that we can deliver to devices in our circuit. And our circuit is going to have a light bulb, and we're going to connect it across the positive and negative terminals. We connect it via wires, which are conductive. Now, when we connect this light bulb across the battery, it's going to light up because there is a current present in the circuit. And a circuit means a complete path from the positive terminal all the way through all the circuit elements down to the negative terminal. And what a current is a flow of electrons. These flow of electrons happen and they do some work and something happens. For a light bulb, when electrons go through it, it will light it up. Now, when this light bulb lights up, there's going to be something called a current present. And what a current is, it's a flow of electrons that will flow from the battery. So we can think of current as coming from the positive terminal through the light bulb, going back into the negative terminal. We're going to put little arrows here to show which way it's going. And I'm going to just arbitrarily choose that this light bulb, when it's connected to a battery, it's said to draw 10 amps. Now let's put something in our circuit that's actually not supposed to happen. So let's say a stray wire or a conductor comes across our circuit and falls right here. When it does connect like so, from the positive terminal through the wire or conductor to the negative, it's actually going to demand as much current as possible. And what this means for the light bulb is that this 10 amps is going to fall down to 0 because current's going to come through here, and this is only asking 10 amps. The wire is asking for all of the current, so all of the current will just flow through the wire. And what happens is this battery can source as much current as possible, which means it'll start climbing from 10 amps, 20 amps, 30 amps, indefinitely. And when that happens, wires can actually only handle so much current. There will be a point that the current will be so high in this wire, it'll actually start getting hot and begin to smoke. After a while, this circuit will catch on fire. And we do not want that. As shown, electrical fires are bad, and this is why we use a fuse to prevent them. So now we're going to incorporate a fuse into our circuit to prevent it, and I'll show how this works. I'm going to draw this fuse right here. These are the two little metal legs over here. I'm going to draw the red plastic box here. And then I'm going to draw the actual fuse element here. Alright, so when I connect these wires like so, the current will draw 10 amps. It comes through here, through the fuse's terminal, through the fuse link, back out the fuse, up through here, through the light bulb, and back into the battery. It's just a piece of wire, just like the other ones over here, with one key difference. A fuse has a current rating. And for this fuse, I'm going to say that it has a current rating of 15 amps. What this means is the fuse will only break or blow when the circuit here exceeds 15 amps. Just like in our previous example with the electrical fire, a stray piece of wire comes by, like so. When this happens, the current through here, and through here will rise indefinitely. The current here is 0 because this piece of wire consumed all of the current, leaving none for the light bulb. So as soon as it hits 15, 16, 17, 18 amps, and it'll do this very quickly, this fuse link will actually heat up, just like the wire would, but it heats up a lot sooner. And when it heats up to the point past the breakage current, it'll actually blow. And when this blows, there will be no more current in this circuit. And since there's no more current in the circuit, the light turns off, and there's no current in this line or in this line or anywhere in this circuit. So now we actually get to the troubleshooting part. How can we actually troubleshoot this to test to see if the fuse is broken? In a practical application, you're only going to see your battery under the hood, your fuse in the fuse box, and your headlight. So there's this tool, it's called a test light, and it's actually just a light bulb. So I'm going to do a light bulb here. And if you took your test light and clipped it on to the negative of the battery, you can use the other end to actually probe spots in your circuit. And like I said, you're only going to be able to probe this point or this point. And if you look on a real fuse, there's going to be these little metal dimples here. Those little metal dimples are actually these points here, which connect to either end. You're not going to be able to actually probe the wire. You'll just be able to actually probe these little dimples here. So if I took this light bulb and I probed it here, let's say, you're actually going to have current coming through here, can't go there because it's broken, back through here, light bulb will light up, back to the negative terminal. So you at least know that this spot here has a positive connection to the terminal. If you were to actually now take this and connect it to this spot, if you follow the circuit through, from positive to this terminal here, you actually can't go through here because the fuse is broken. It would have flown through here, but since it's not, the light bulb will turn off. And in reality, you're going to have many fuses in a line, and you can actually take your test light and keep on poking through until you find a fuse that lights up on one side but doesn't light up on the other. And actually, here's a test light right now. If you look in the clear handle, there is this light bulb in here. One end of it is actually connected through this metal probe here, and that's the positive probing side. And the other end is actually connected through this wire up to this little clip here. So this clip is actually the wire that goes here, and this probe is actually the spot where you're probing in your circuit. So if you actually were to connect here, the light would light up. If you were to connect here, it would light up. Connecting here, it wouldn't light up. So you would say this fuse is blown. If you replace this fuse with a good one, assuming you knew why it blew in the first place and you cleared out the short circuit, which is our wire here. Let's say you went under the hood and you found out that you forgot a screwdriver in there. You removed it and everything was great. So you replace the fuse back with its proper rating, 15 amps in this example. If you were to probe here, it would light up. And if you were to probe here, it would also light up, showing that you successfully changed the fuse out. So now that we've actually went through how a fuse works, what it's used for, and how to actually poke around a circuit and troubleshoot to see if one is broken or not, or blown or not, we can actually go out to my car and start testing some fuses out. First thing I want to do is test to see if my test light that's been sitting in the garage for a while actually still works. So to do that, I'm going to test it against my car battery, because I know that works. So I'm going to pop the car hood. I'm going to walk on over, open it up, and locate the battery. Taking a closer look at our battery, we can see that there are two metal posts. You might have them on top like I do, you might have them on the side. You're going to find two metal posts nonetheless. On the actual battery case itself, we're going to see a dash symbol indicating the negative terminal and a plus sign indicating the positive terminal. Mine also has a plus sign on this cover here. You may have a cover on both terminals or one terminal like I do here. If you do, just remove them both. They're easy to clip off. Next thing we do, we take our clipping part of our test light and we clip it on to the negative part of the battery. Now we take our probing side of our test light and we're going to probe the positive side of our battery. And it lights up. This means that my test light is working as it should. If yours doesn't light up, you might have a bad bulb inside and you'd have to unscrew this and change it. You might have a dirty contact on the probe, a dirty contact on the clip, or you might actually have dirty contact from all the dirt and the grime from the battery posts. Just clean them off with a coarse brush, try again, and it should work. The next thing you do is to find out where your fuse boxes are actually located to start testing. Looking in your user manual underneath maintenance and service or something similar to that, you can find out where they are. Mine has two fuse boxes and one is located right next to my steering wheel and the other one is located right next to my battery. So let's go look at those. I'm going to first start out with my fuse box underneath my steering wheel here. And I found a little door here with a little kind of like a recess here. I can put my hand and kind of flip it open. And when I open it up, we can see that there are a bunch of fuses here in this plastic box here. This thing, the door itself, can actually pop off in some cars. Mine does, I know that for a fact. And if you look at the cover, you'll probably find something like this. And it's kind of like what a box of chocolates has. It shows you what kind of fuse rating it's going to be for each spot and what that fuse is connected to. For my car, I actually have a problem with my cigarette lighter. It actually doesn't power up my phone anymore, so I'm thinking that it could be a blown fuse. So I'm going to go look through this list and find something that could be relating to a cigarette lighter. And as I make my way down the list, I actually find something called cigar, and that's most likely the fuse that I have to check. I can see here that it says 10 amps, and it should be located on the lower left corner, so let's go check that out. But before I can actually test the fuse in that fuse box, I actually have to take my clip and connect it to the negative end of the battery, and then start poking it with the other end in the fuse box. But I know for a fact that when I clip this to that negative terminal, and I try to make my way to the probe in there, to the fuse box, it actually doesn't reach. So what do? Fun fact, the negative terminal of a battery is actually connected to most or all the metal on a car chassis. So for example, if I pick a bolt that's coming out of the car chassis here, something that's not painted on the actual part of connection, if I took this clip and I connected it to my bolt here, and I took my probing part here and I touched the positive terminal of the battery, it lights up. This is because this terminal is also connected to that piece of metal here. So essentially, anything that's, or mostly anything that's metal in a car, is actually also connected to that terminal. Now that I got my negative clip part of my test light connected to something that is connected to the negative part of the battery, I can actually start probing around with my test light. And I know from the panel, from the fuse box, that I'm looking for a 10 amp fuse that is on the lower left corner of this fuse box. Zooming in a little more, I can actually see that fuse right over here. So let's probe and see what happens. Probing the one side, nothing lights up. And probing the other side, nothing lights up. Why do you think that could be the case? Well, if you remember from the pencil and paper demonstration that I showed you on the fuse and the battery, I actually drew a wire straight from the leg of the fuse to the positive post of the battery. In practice, however, there's a switch in between them that actually disconnects and connects that fuse to that positive part of the battery. And since this is a cigarette lighter fuse, I know that this circuit will only connect to the battery when the car is turned on. And that's actually for most fuses in this panel here. So in order to test a fuse box, you have to have that circuit active or activated by a switch. So I'm going to take my key right here, going to put it into my ignition, turn to the on position, and now I should have this cigarette light circuit active on one side if it's a blown fuse. So trying again, we're going to probe the bottom part of the fuse. No light, okay? So this end here better be the side that connects to the positive part of the battery. And bingo, it lights up. So this spot here is the side that connects to the positive part of the battery. If this circuit had been working correctly, this part over here should light up. Let's try another fuse to see if it lights up. Going to the next fuse over here. That one doesn't light up, nor does that one. And that means that this circuit is off. Let's try the next fuse. This one lights up, and this part of it lights up as well. So we can tell that this fuse is working correctly for this particular circuit. This fuse here, since nothing lights up, means that this circuit is off and the fuse may or may not be good. For this here, the one that I'm investigating, one end lights up and the other one doesn't, indicating that this is a blown fuse. So let's pull it out and see what it looks like. What I usually do is I'll use needle nose pliers and I'll grab the fuse and I'll just pull it out. Sometimes on your fuse door here, you'll have a little spot that holds a plastic clip, and those are called fuse pullers. Mine didn't come with them for this fuse box, so I'm going to just use my pliers. So I'm going to just take my pliers, open it up. Don't squeeze too hard, just gently apply pressure and pull. Alright, and let's take a look at our fuse. And if we actually look, this fuse, it looks blown. That little filament in there looks like it got destroyed. It's all deformed looking. If we took a good fuse, let's say this one over here, because we knew it was good. Let's pull that one out. Just for example, that one has a nice little link in there that has a U shape in there. That looks good. Compare it to the one that we think is bad. That one's all deformed. So this is definitely a bad fuse, and this should definitely be replaced. Now luckily for me, I actually had a good looking fuse, a spare one, back in my workstation. If you don't have one, you could buy one for pretty cheap. Just bring in your old fuse to a auto parts store or a hardware store, and they'll know what size to get and as well as the exact current rating. Now you don't really need pliers or anything for this. It might make it easier. I'm going to use just my fingers here, and you'll notice that actually, since this is just merely just a piece of wire, this can go in any orientation, so it doesn't matter which way it goes. So I'm going to put it in this way and just push it in here. And there you go. Pretty snug over there. So now let's go look to see if this fuse is working now. Taking our test light. Let's poke the one side here. And this side initially was off. Let's try the other side just for a sanity check. And that one's also working. So that means that this fuse has been successfully replaced. As a side note, I actually replaced this fuse knowing full well what caused the fuse to blow. When I looked at my cigarette lighter, I actually found a penny inside there. And that penny most likely short-circuited the positive and the negative terminals inside there, causing an elevation of current high enough to go over 10 amps and actually blew the fuse. You may or may not be able to find what the problem is in your car. You could always try to put another fuse in there to see if it blows. If it does blow immediately, there is a problem with that circuit and you will need to have it inspected by a mechanic. Alright, with that being said, let's close this box up here. And let's take a look at the actual other fuse box, just to see how it looks like. So here we are at the other fuse box underneath the hood. That's by the battery. It's covered by this plastic piece over here, and it has these clips here kind of locking into place. Yours might look similar if you have one under the hood. And if I actually just push this pin in here and gently pull it out, I can reveal all the fuses underneath the plastic piece here. And if you look, just like in the other fuse box, there's this map of all the fuse locations, what they connect to, and their current ratings. And actually, if you look over here, they were so nice, and they actually gave us spare fuses just in case any of these fuses blew. Looking further in here, you'll find actually for this fuse box, they have these little plastic clips here, and that's the fuse puller I was talking about beforehand. But I use pliers instead because I just found them easier. Taking a closer look, we can actually see the fuses that I showed you initially in the other fuse box and on paper. And here are the fuse pullers I was talking about. But what are these guys? These are actually different kind of fuses, and they look a lot different from what these guys are. They still have a number printed on them, and if you look inside here, you'll still see a fusible link. Unfortunately, if you took your probe, you couldn't actually poke in here because it's covered by plastic. So I'm going to show you how to test fuses that look like this, just in case you come across this for your car. So I just pulled out that same fuse I was pointing at with my pliers and showing you a close-up of it. You can kind of see the little piece of metal that'll break or blow if it goes beyond 30 amps. On the other side, you can see these two slots in here, and these two slots have a little metal piece in each one, and that's where the fuse actually connects into here. So you could test for this fuse by looking at it visually to see the piece of metal is connected, and it does look like it's fine, but you can't rely on your sight to test for a fuse. What we're going to have to do with fuses that you can't directly test with a test light is to use something called a multimeter and do a quick continuity check. And what a continuity test is something that can tell you if a certain material is conductive enough to provide a good path for current. We know wires are good conductors because they're made of metal, and these pliers should be also a good conductor here as well. So I'm going to use this as a test to show what a continuity test does. Multimeters will perform continuity tests pretty easily, and if you've never seen one before, they usually have a dial, a bunch of settings, they'll have a screen and maybe some buttons on the side for options, and they'll have a bunch of ports here. Two of these ports can be used to be connected to two probes, and if you refer to your user manual, you'll know which ones to plug into to use a continuity test. If you don't have a multimeter, they're pretty easy to find at a hardware store and pretty inexpensive too, so it's worth investing about $8 to $10 just to have one lying around the house for simple projects like this. So to start out, I'm going to take my dial and set it to my continuity test, and it'll display something here just to show that it's on. Now in a continuity test, typically when you take these two leads, it'll show a 0, but more commonly it'll actually beep as a pretty indication that whatever you're touching between these two probes is conductive. So when I touch these two probes together, it's telling me that when it beeps that between these two probes, whatever I'm touching is conductive, and these probes are metal, so they should be beeping. So as an example, if I went to these pliers here, they're metal, they should be conductive, so if I poked two spots on the pliers, it should beep. And it does, showing that this plier is a good conductor. If I took something else, let's say I tried to measure the ground here, this stone block over here, between 2 points to see if it's conductive, we don't hear a beep, which means that I can't get current to be present in this stone had I applied a battery to it. So let's try applying a continuity test on a known good fuse. So for this fuse, the one that I showed earlier, has these two slits here where it connects to, and making sure my continuity test works. Let's try it on the actual fuse. And it works. So that means that this fuse passes the continuity test and is good to go. Now let's try our bad fuse. Luckily for us, this was so burnt out that we were able to tell that it was a burnt fuse. But you might come across a situation where you go with your test light and you'll find out that one side doesn't seem to light up, and when you pull it out, this element still looks like it's in contact. It might have been just enough current to break it, but not enough to visually see it. So the best way to test is our continuity test. Test and see if it still works. We go across our fuse here, these two legs, and I can't get anything to beep, which means that we definitely know that this fuse is bad. And that's really it. Hopefully this video gave you the confidence to check your own fuses in your own car. Subscribe, thumbs up if you liked the video. Any comments, please post them below. Thanks for watching.